ओके गाइज, वेरी गुड इवनिंग टू ऑल ऑफ यू. ओके, तो सभी को मेरा नमस्कार, सत श्री अकाल, आदाब, गुड इवनिंग. So guys, today here on this platform we are going to start the subject heat transfer. And as far as subject is concerned, this subject is very important for chemical engineering prospect. This subject is important as far as interview is concerned and as far as any examination that related to the chemical engineering discipline. And apart from the examination or application, this subject is also very important to understand the different physical, different practical application, different practical examples that we always goes through the daily life. So there are various daily life examples are there. There are various daily life examples are there in which the heat transfer phenomena takes place. And you all might be aware through these examples. Good evening. For example, जब भी आप उठते हो तो आपको सुबह सुबह गर्म पानी पीते हो या चाय पीते हो, तो ऑब्वियस बात है कि दैट इज़ आल्सो एसोसिएटेड with the heat transfer phenomena, because if you are going to take the hot glass of water or hot coffee or hot tea, then obviously you will see that after some times the temperature of the tea will goes down, and the reason is the heat transfer. And there is not one example, various examples are there. For example, if you are going to stir any hot liquid with a spoon, or if you are going to place the spoon in a container which filled with the hot liquid, then you are able to find that one end of the spoon is going to be heated. That is obviously because of heat transfer. Thank you so much. तो देर आर वेरियस एग्जाम्पल्स आते हैं, और ये अगर हम बात करें कि इसके कई सारे एप्लीकेशंस की एग्जाम्पल्स की, तो इसके साथ थोड़ी बेइज्जती होगी. क्यों? क्योंकि बहुत सारे एग्जाम्पल्स हैं. देर आर वेरियस एग्जाम्पल्स आर देयर, देर आर नॉट वन एग्जाम्पल्स. तो बहुत सारे एग्जाम्पल्स हैं. इफ़ यू आर ईटिंग अ हॉट समोसा, then obviously you have to blow air to cool the stuff under the samosas or patties or burgers. So that is why you are going to blow the air, just only to increase the heat transfer so that the object will cool faster. Okay, it means the blowing air just to enhance the rate of heat transfer so that we can cool the object in small time. So that is all, or the examples are there that is associated with the heat transfer. Okay, so as well as practical example is concerned, as well as examination point of view is concerned, from all prospect this subject is very important. And as far as exam point of view is concerned, it includes around 8 to 10 marks in the gate examination. And as far as interview point of view is concerned, in each and every interview, the frequently number of questions has been asked from these subjects. That's why this is very important subject. Okay, so here we are going to start the subject heat transfer. So please, which color? White. Is it visible? Heat transfer subject. Karthik. Heat transfer. Okay guys, first of all, before discussing how can you define the heat, actually guys, the heat is a form of energy. Heat is a form of energy. As you know, there are various forms of energies are there. As in the class of process calculation, I have already discussed that there are various forms of energy are there. One, and we can segregate different form of energy in two way. are in two parts. One is energy in stored form and energy in transit form. So first of all, before discussing about the heat, we should discuss about energy. Energy. So we can segregate the energy in two form. First is energy in stored form. Energy in stored form, and second is called as energy in transit form. Energy in transit. Energy in stored form and energy in transit form. My dear student, energy in stored form means energy which has been stored, and energy in transit means energy which are in transferring mode. Means if any energy which has been stored, it cannot be energy in transit, because as the name suggests, transit means transaction. There must be a transfer. So any energy which can be transferred is called as energy in transit. And only two ways are there to transfer the energy between system and surrounding. There is two ways to have interaction between system and surrounding, and that is called as heat and work. So energy in transit means the energy which can be transferred, and energy in stored form is energy which has been stored. For example, if you have a container, if you have well insulated container, just try to understand, my dear student. If you have a well insulated container, and in that well insulated container or adiabatic container, you have placed the hot liquid or hot fluid, then obviously, since the container is adiabatic, no energy can be transferred from system to surrounding or from surrounding to system. It means whatever energy is there due to hot liquid, that is stored energy. It cannot be transferred. Means whatever the energy which has been stored in the adiabatic container, that is only stored energy. That cannot be energy in transit. Are you getting a point? But if we have removed the insulation, then what happened? Now there is a transfer of energy in between system and surrounding, either due to temperature difference or due to any other medium, any other way, and that is called as work transfer. So if energy is going to transfer from the system to surrounding, that is called as energy in transit form. Are you getting a point? Yes or no? Please tell me. Energy in transit form means this energy can only be energy in transit means which present during only transferring processes. The energy which can be transferred between system and surrounding, that is called energy in transit, and that can be either heat or work. It can be either heat or work, or both, heat and work. Energy which has been stored. Energy can be stored in the system in two forms. One is called as microscopic and macroscopic. Okay, here you can write energy stored can have a two form. One is microscopic and macroscopic. Microscopic and macroscopic. Micro and macro. Energy which can be stored in the system. Micro and macro. And my dear student, once again, if energy is stored in the system, it can neither be heat nor be work, because heat and work are two forms of energy which can only be identified, which can only be manifested when they are in transfer mode, when the energy will get transferred. It means whenever energy will get transferred, then that energy can either be heat or work. But if energy has been stored, then it can neither be heat nor be work. Is this clear? It means, in simple language, you can say heat and work are the two forms of energy which can be only identified or manifested when the energy is going to be transferred, or energy should be in transit mode. Okay? Yes, obviously. Chirantan, obviously, if whatever energy you have stored, for example, Chirantan, if you have a closed vessel is there, and this is adiabatic, and here you have removed. Wait, क्या हो रहा है यार? Wait. Hello. Okay. Okay, good. Now listen here. Chirantan, you have asked if energy will get transferred because of heat or work, then obviously the stored energy will get decreases. That is the first law of thermodynamics. And the first law of thermodynamics says the conservation of energy principle. And the conservation of energy principle is that ki energy can neither be created, cannot be destroyed, it can only be transformed from one form to other form. It means whatever energy you have stored initially, that will get decreases. Why decreases? Because of transfer of energy due to heat transfer or work transfer, or by both. Is this clear, Mr. Chirantan? Aswarya, that is very obvious ki if initially the system is adiabatic and let's say 20 kilojoule of energy has been stored, now if you have removed the insulation, then energy can neither be created, you cannot be destroyed, it can only be transformed from one form to other form. So whatever the stored form of energy will be there, some part of stored energy will get transferred into the transit form. Is this clear? Okay, very good. So that is here. Now come to the point here. I've told you energy in transit is heat and work, and these two forms of energy can only be identified when the energy will get transferred. Okay, now energy in stored form, energy can be stored in two form. One is microscopic and other is called as macroscopic. Okay, now here I am going to clarify again. Microscopic and here macroscopic. Micro and macro. Now they are part of stored form. So what is microscopic? Microscopic form of stored energy is due to what? Anyone? Due to internal energy of the molecules. Due to internal energy of the molecules. Are you getting my point? Yes or no? I've discussed these things in the process calculation. Am I right? Please tell me first. So my decision, microscopic form of energy is called as internal energy. Internal energy. So what is internal energy? Energy which has been associated with the molecular motion, or energy that is going to be associated with the translation, rotation, vibration, spinning, nuclear energy, chemical energy. These forms of energy stored is called as internal energy as a whole. Means any energy, because whatever molecules that comprise the substance, every substance are made of various molecules. Are you getting my point? Now, so and whatever molecules that comprising the substance will have a rotational energy, because molecules are going to rotate on its own axis, they are going to vibrate, they are going to translate, they are going to be spin. So according to this, whatever energy of the molecules that is going to be associated with the translation, rotation, vibration, spinning, nuclear and chemical energy. That all energies has been combined in a common form is called as internal energy. Is this clear? So microscopic forms of energy is called as internal energy, and macroscopic forms of energy is because of what? Kinetic and potential energy. Is because of kinetic and potential energy of the molecules with respect to some reference point. Are you getting my point? For example, let's say the microscopic is the energy that is going to be associated with the molecules, and that is the energy that is going to be associated with the position of the, not molecules, that is the position of the group of molecules. That is called as energy that is going to be associated with the position and due to velocity with respect to some reference point, called as kinetic and potential energy. Is this clear? Very good. That is called as kinetic energy plus potential energy. For example, it's very simple. If this is a substance, and this substance is consisting of various molecules, so whatever energy is going to be associated with the molecules, for example rotation, translation, vibrations, they are called as internal energy as whole. And if, since this substance is at a reference state, and if this substance is going to move from one point to other point, suppose its position has been changed, so due to change in its position from the reference point, it has potential energy mgh. Are you getting a point? If any substance is ever from its reference states, has potential energy, and if any substance is going to be move with the velocity that is from the reference velocity, let's say here reference velocity is v1 and it's moving with the velocity v2, then what happen? It will have also the kinetic energy. So that is energy not due to molecules, that is energy due to fluid element, and fluid element is the group of molecules. So that is the kinetic energy and potential energy, and that is also called as mechanical energy. That energy is also called as mechanical energy. Are you getting a point? Yes or no? So that is all about your classification of energy. First of all, I have discussed to you कि energy, forms of energy. Energy can be classified in two parts: energy in stored form, energy in transit form. Energy in stored form can be further classified in two parts: microscopic and macroscopic. Microscopic is the energy which has been stored in the system at the molecular level, that is associated with the translation, rotation, vibration, chemical, nuclear energy. That is called as microscopic form of energy, and as a whole it is called as internal energy. Now at the same time, second is called as macroscopic energy. That is energy associated with the position from the reference state is called as potential energy, and its velocity with respect to some reference velocity is called as kinetic energy. So that is called as kinetic energy and potential energy of the fluid element or group of molecules. Okay, that is called as macroscopic, at the macroscopic level, not at the microscopic level. It is clear? Now second is called as energy in transit form, and listen here, that microscopic, macro, macroscopic form of energy is also called as mechanical form of stored energy, called as mechanical form of stored energy. Now second thing, come to the point, energy in transit form. As far as energy in transit form is concerned, my dear student, energy in transit form can be either heat, or it may be work, or maybe the both. Then how can you differentiate between the heat and work? If energy in transit is because of temperature difference, if energy in transit, it means if the energy transfer is there in between substance or from one substance to other substance due to difference in temperature, that energy in transit is called as heat. And if energy in transit is not because of heat transfer, that energy in transit is called as work. Are you getting a point? How can you differentiate between the heat and work? Now heat is a form of, then here the very important, as the subject is heat transfer, the first question that can be arise in your mind, ki how can you define the heat? The first question that must be asked from anyone, ki how can you define the heat? Then your answer should be, heat is a form of energy in transit due to, because transit is also the work. So how can you specifically define the heat? Heat is a form of energy in transit due to temperature difference. Are you getting a point? Yes or no? Yes, very good. So now you can define the heat. Now you can define the heat. Heat is form of energy in transit due to the temperature difference. This is the definition of the heat. Is this clear, anyone? If you have any doubt, you can ask me. Not thermal potential difference, thermal temperature difference, you can say. Heat is a form of energy in transit due to temperature difference is called as heat. Anyone have any problem, my dear student? As I've told you, internal energy, please you can write. I've told you internal energy is the form of stored energy in microscopic form, or internal energy is the microscopic form of stored energy. So I can further classify the internal energy. Please write down. Internal energy. U total internal energy, which is the store. I told you internal energy क्या है, that is the microscopic form of stored energy, and that I can further classify in two parts. Other form, and here you can write thermal internal energy, other energy and thermal energy. Please write down. Internal energy can be further classified into the other form of internal energy and thermal energy. Is this clear, guys? So other form, that is thermal energy due to rotation, due to translation, due to vibration. So all energy, listen here, and that is other form means that is because of nuclear and chemical. That is internal energy that I told you, no? Internal energy, the sum of energy that is going to be associated with the molecules because of chemical energy, nuclear energy, and rotation, translation, vibration, and all. So all this thermal energy is includes the energy because of translation, rotation, vibration, spinning. But other are only because of nuclear and chemical. Nuclear plus chemical. Clear hai? And these energies includes the energy that associated with the temperature, and because it means as the heat will increase, their energy is going to increases. So energy, internal energy can be further classified in two parts. One is called as other form of energy called as nuclear and chemical, and another is called as that is energy associated with the rotation, vibration, translation, spinning, etc. And this energy called as thermal energy. Clear hai? You can write in your own, otherwise you can understand everything you can't write. Clear hai? Yes or no? Sagarika, I told you कि internal energy is the energy that is going to be associated with the molecules because of rotation, translation, vibrations, spinning, nuclear energy, and chemical energy of the molecules. So here we are going to segregate nuclear and chemical, and rest are called as thermal energy. Rest are called as thermal energy. And that thermal energy we can also classify in two parts. Sensible and latent. Sensible and latent. What is meaning of sensible? Sensible internal energy means what? Anyone? What is meaning of sensible? If any energy that possessed by the molecules which are directly associated with the temperature is called as sensible. Means as temperature will increase, then sensible energy will increase, then thermal energy will increase. Now, and the latent energy will includes the intermolecular phase change operation. For example, if any substance is there that is going to transfer its phase from vapor to liquid, or from liquid to vapor, or from solids to liquid, or liquid to solids. Is this clear, yes or no? Yes. Latent heat, that is because of intermolecular phase change, and that is due to intermolecular change in temperature. It means the thermal energy is the two types of thermal energy is there. One is sensible thermal energy and latent heat. U sensible and U latent. In short form, you can write U sensible and here U latent. And if there is no phase change operation, then what happens? This term will be 0. Are you getting a point? Yes or no? If there is no, yes, very good. The sensible, not sensed. Sensible means, yes, you can say sense. If temperature will change, then you can sense. That is obvious. But sensible thermal energy means the energy that is going to be associated, that causes the temperature to be increased or decreased, called as sensible thermal energy. And latent means that is associated with the phase change operation. Temperature remains constant. Clear to everyone? Now, if the process, and this is the part of energy stored. For example, it's very simple example is that, let's say if you have a system, this is your system is there. Let's say you have a container, and this container you have a ice. In this container, let's say you have ice. That is ice. And if we are going to transfer, let's say we are going to transfer the energy from the surrounding. This is the container. In this container the ice is there. Then what happens as the energy will transfer from system to surrounding, then what happens? This ice is going to be melt. And let's say this ice is at its saturation temperature. It is very important. If ice, let's say, if this is the ice and ice is at its saturation temperature condition. What is meaning of saturation temperature condition? Anyone? तन्मय, फेज चेंज हो रहा है तो टेम्परेचर चेंज नहीं होगा. अगर केवल फेज चेंज हो रहा है, इफ देयर इज ओनली फेज चेंज देयर इज नो टेम्परेचर. मिस्टर तन्मय, यू शुड नो कि ड्यूरिंग फेज चेंज ऑपरेशन टेम्परेचर प्रेशर रिमेन्स कांस्टेंट. मिस्टर तन्मय, if you are going to listen, phase is only going to be changed if your substance is at its saturation condition. For example, if you have Tanmay, if we have a liquid is there and this liquid is at its condition of saturation. What is meaning of saturation? It means at 1 atmospheric pressure the temperature of this liquid water should be 100 degrees Celsius. Then this liquid water is said to be called as saturated liquid condition. And this temperature is called as saturation temperature. Are you getting a point? Yes, very good, excellent. Tanmay, it is clear? So that's why it is very important. If you want to carry out the phase change, then the substance must be at its saturation condition. So here, let's say you have ice and ice is at its saturation condition, and if you are going to transfer the energy either due to heat or due to work, then what happens? This ice is going to be melt. This ice is going to be melt. Am I right? Yes or no? Then here the change in internal change in energy of the system from the first law of thermodynamics, what you can write? Energy in minus energy out should be energy accumulation. So here E dot in minus E dot out is equal to rate of change of accumulation within the system. Am I right? Yes or no? That is a simple energy balance there. Energy in minus energy out is equal to rate of change of accumulation of the energy. Am I right? Within the system. Please tell me, any problem? Now here energy is going to be in. Yes, I don't know, it may be either heat or it may be work. And even if it is the heat transfer, then we don't know what is the mode of heat transfer. Mode of heat transfer may be convection, conduction or radiation. Am I right? There must be a crush question in the mind. Now here energy, let's say there is no work transfer. The energy can be in because it is a rate of energy in. Energy in means there should be an interaction, and interaction energy is going to be in from surrounding to system either by the heat or work. Let's say no work is there, then energy can be transferred by the heat transfer. But again the question is that what mode of heat transfer is there? Conduction, convection or radiation? Very different part. But we should know. Then only we can write the corresponding equations. So we can't write minus k dt by dx Fourier's law unless we are not going to be confirmed that this energy transferred by the heat is only by conduction, because heat can be transferred either by conduction or by convection or by radiation or by the all three modes. Are you getting a point? So here In this case, as no energy is going to be out, all only energy is going to be in. And let's say energy in by heat transfer, that I can write later on. E dot, this is different part, minus 0. And it is very obvious if energy is going to be in, whatever energy will get in, where it goes? Obviously, my dear student, it will increase the internal energy of the system. Am I right? Yes or no? And that here, as let's say, energy, that is stored energy, na? This is the rate of change of stored energy in the system. That is the rate of change of stored energy. And stored energy has two forms. One is microscopic and macroscopic. Listen, we are always going to be shortcut, but we should know the logic behind that. Stored energy in the system may be macro and micro. And macro is because of kinetic energy and potential energy. And if system is stationary, this system is not going to move anywhere. If this system is not going to move anywhere, there is no change in kinetic energy and there is no change in potential energy. तो माइक्रोस्कोपिक फॉर्म ऑफ स्टोर्ड एनर्जी विल बी जीरो. यस और नो? भाई जो भी एनर्जी जा रहा है वो स्टोर्ड होगा. तो स्टोर्ड में क्या चेंज हो रहा है? Whatever the rate of energy in, that will increase the internal energy of the system. That will increase the internal energy of the system. But which energy? Now again we can further classify. As we know, stored energy has two forms, macro and micro. Macro form, that is because of mechanical form, called as kinetic energy and potential energy. These two energies are only going to be important if the system is going to be moved from one point to other point. Since system is stationary, अगर सिस्टम एक जगह रुका हुआ है तो देर इज नो चेंज इन काइनेटिक एनर्जी, देर इज नो चेंज इन पोटेंशियल एनर्जी. दैट फॉर्म इज zero. Now only energy stored is what? Microscopic. In microscopic form of stored energy, my dear student, if there is no chemical, no nuclear energy, that substance has no chemical nature, no nuclear nature, then the only energy is called as either sensible or latent. Now, are you getting a point? And since there is no change in temperature, molecules are freeze, or you can say there is no sensible energy, then only the energy is what? Latent energy here. In this case, only the energy should be what? du of latent of dt. Am I right? Yes or no? Please, for this example, here I am going to write only for this example when the ice is at its saturation point, or if liquid is there which is at its saturation temperature, or you can say solid is there which is at its saturation temperature. Whatever the phase is there, that must be at the condition of saturation. And here I can write d upon dt, and this should be m. This is the mass of that ice into lambda, latent heat of fusion. Am I right? Yes or no? Yes, obviously. Ice is only at Tsat. Otherwise, it should be the boss, sensible plus latent. Are you getting a point? Because there is no sensible, there is no change in temperature. Only we are going to discuss the phase change processes. We are transferring, listen, it is very important. Here in this case, we are transferring the energy only for that time period, where the phase will change. Otherwise, once the phase will change, then what happens? Temperature start increasing. Are you getting a point? But here, whatever this energy will get transferred in the system only for that time period up to which the phase will going to change. Once the phase has been changed, now no energy will get in. Is this clear to everyone? Now, once again, I am going to discuss here one more thing. Let's say if you have again same container, and this is the container, and that is filled with the liquid now here, and this is there is no latent heat, there is no latent, there is no phase change operation. In this case, if initial temperature is Ti of that substance, or let's say T1, what happens? If energy will get in this case, how can write energy balance? My dear student, E dot in minus E out is 0 equal to d of E of system over dt, and here E dot in minus 0, and here energy system is stationary, there is no nuclear, no chemical, then only energy is what? Sensible energy. Then here du sensible over dt, that will cause to increase temperature. Am I right? M lambda, so bro, M lambda, latent heat. Anyone have any doubt? That is very common. It is law of conservation of energy. So bro, this is M lambda. Now, not I think, I am going to discuss here. Not I think, it will be. Then here, in this case E dot in minus 0, that should be equal to what? Now if this liquid is incompressible, or if this fluid is incompressible, then as you know from thermodynamics, why du mcv dt, do you know? Du equal to mcv dt, and m is the mass, and this mass I can write here volume into density. If we are going to assume the liquid is incompressible, then if liquid is incompressible, that du should be what? U sensible, mcv dt, mcv dt upon dt. And this m, if this fluid is incompressible, then what happens? Rho into v into cv into dt over dt. Is this clear? Yes or no? And I told you in thermodynamics, if it is a liquid, then for liquids and solid there is no meaning of cp and cv, but for gases it should be only cv. Are you getting a point? Yes or no? Please. So directly we are going to write mcv dt upon dt many times, but what is the logic behind that? Now it is clear, yes or no? Now my dear student, if the same question which has been asked to you, instead of sensible energy, if there is a latent heat of phase change is there, then all of you will get confused, all of you are not able to solve, because most of the time we are always going to write d equal to what? mcv dt upon dt. But what is the logic behind that? That is, we can only write if there is no phase change operation. If liquid is incompressible and cv, specific heat capacity, is not a function of temperature, then we can write rho v cv dt upon dt. Is this clear? Dekho, that is the logic. If the same question I have asked you, ki now this liquid is saturated liquid, then what happened? And the energy has been transferred to the time that is lower than the time required for the phase change, time required to vaporize the liquid. In this case, you should write that dt should be this should be m lambda, du should be m lambda. Are you getting my point? Yes or no? Mr. Yuras, I told you which point? Here mcv, because d equal to mcv dt, but at the same time I have told you ki cv and cp is same for the liquids and solids, because liquids and solids are incompressible and there is no meaning of cp and cv. But if gases are there, if the fluid is gas, then you should write the cv. Clear? And I have told you, if this fluid in the system is at saturation condition, then here you should write, and there is no sensible, it is given in the problem, there is no sensible heat change, sensible change, then you should write m lambda. Clear? So that is the all about your introduction about the heat. Is this clear? How can I define the heat? My dear student, heat is a form of energy in transit due to temperature difference. Okay. Now, so that I have defined the heat, definition of the heat. Now, there is always difference, there is always confusion between the two terms, thermodynamics and heat transfer. My dear student, someone can ask me, sir, what is the difference in the thermodynamics and heat transfer? As in the thermodynamics also, we are calculating the amount of heat transfer, and in the same thing we are also going to be done in the heat transfer, like calculation of the heat. Then what is the basic difference in the thermodynamics and heat transfer? Because thermo means heat, a power, thermo means power, dynamics means what? Thermo means heat and dynamics means power actually. So what is the basic difference in thermodynamics and heat transfer? Because in thermodynamics also, the first law says Q minus W is equal to delta U or delta E actually. Am I right? Q minus W equal to delta E, that is from thermodynamics. So if no work transfer is there, then we are going to calculate the Q also. Q is also the heat, amount of heat. Then what is the requirement of subject heat transfer, my dear student? It is very, very important. Thermodynamics deals with the calculation of amount of heat transfer only between two end states. Only between two end states, and every states in the thermodynamics will be in equilibrium. What is meaning for that? It means, let's say if you have a system and system is there and here surrounding is there. Try to understand. System is here, surrounding is here, and if heat will get transferred, heat is going to be in Q dot. heat is going to be in from surrounding to system, then obviously here the internal from the, and no work is there, then from the first law of thermodynamics, whatever amount of heat transfer is there, that will increase the internal energy of the system. Am I right? Yes or no? That will increase the internal energy of the system, and as the heat will get transferred, the internal energy of the system is going to be changed, and as the internal energy of the system is going to be changed, that its state is going to be changed. State means from 1 to 2. It means initially, before transferring the heat, the state was 1, and after transferring the Q amount of heat transfer, state has been changed to 2. Are you getting the point? And every state should be in thermodynamic equilibrium. Every state is in equilibrium. It means in thermodynamics, the amount of heat transfer, amount, not rate. Listen carefully. Thermodynamics deals with the calculation of amount of heat transfer between two end states. Means when the process that will cause to change the state from one end state to its second end states, it means you can say to change the state from 1 to 2, how much amount of heat has been transferred, that I can calculate by the thermodynamics. So thermodynamics can only able to calculate the amount of heat transfer required to change the state from one end state to other end states, and every states are in equilibrium. It means the thermodynamics is an equilibrium phenomena. Thermodynamics is an equilibrium phenomena. Now it is clear, yes or no? What is the meaning of equilibrium? Means to change the state of the system from one equilibrium state to other equilibrium state, how much amount of heat transfer you have supplied or removed, that I can calculate by the by thermodynamics. While the heat transfer, thermodynamics calculates the amount of heat transfer between two equilibrium state, while the heat transfer subjects deals with the calculation of rate of heat transfer, not amount. It calculates the rate of heat transfer. And what is the advantage of rate and amount? Both are different things. With the help of rate of heat transfer, we are able to calculate how fast the equilibrium has been reached. Thermodynamics is not able to calculate how fast, how much time it will require to reach from one end state to other end states. ये केवल ये निकाल सकता है कि कितना अमाउंट ऑफ हीट ट्रांसफर किया आपने जिससे स्टेट चेंज हो गया 1 से 2, लेकिन ये कभी नहीं बता पाएगा कि कितना फास्ट, हाउ फास्ट और हाउ मच टाइम इट विल रिक्वायर्ड to change the state from one end state to other end states. For that calculation, you should go for the heat transfer. Is this clear? Yes, Praveen. Every state means what? Condition. State, Praveen, state का मतलब होता है conditions. Condition. Every state is in equilibrium. Equilibrium means there should be no any change. There is no any macroscopic change. Means temperature, pressure, all are fixed. Called as equilibrium condition. This whenever any system is said to be in equilibrium, thermodynamic equilibrium, it means it is mechanically, chemically and thermally equilibrium, chemical equilibrium and mechanical equilibrium. Thermal equilibrium means there is no temperature difference. Chemical means there is no chemical potential difference. Mechanical means there is no imbalance of forces. Then everything is in the equilibrium condition. There is no change. So if you want to change, then you should disturb the equilibrium, and for that you have to transfer the amount of heat Q. So listen here, thermodynamics deals with the calculation of amount of heat transfer to change the state from one equilibrium state to the other equilibrium state. It means thermodynamics is an equilibrium phenomena, while heat transfer is used to calculate the rate of heat transfer, means how fast the equilibrium has been established, how fast how fast we can change the one equilibrium state to other equilibrium state. Okay, and in design of equipment, it is very important to have a rate of heat transfer, because if you want to design the heat transfer equipment, then we should bother about while the heat transfer subjects deals with the rate of heat transfer. I told you rate of heat transfer is very important in designing of equipment. Why? Because listen, a very simple example I am going to discuss here, my dear student. A very simple example. Let's say if you are going to purchase a thermos in market, okay, then you will find the two thermos. One is of the high quality and the other is low quality. So what is meaning of high quality and low quality? How can you decide it is high quality? It is not up to the mark and it is up to the mark. Please tell me. And both are made of the same material. If you are going to purchase a thermos, and what is the purpose of thermos? The purpose of thermos is to maintain the temperature either lower or higher than the surrounding temperature. Am I right? थर्मस क्यों लेते हो? ताकि जो पानी का टेम्परेचर समर में चाहते हो, इन समर यू वांट टू मेंटेन द टेम्परेचर ऑफ द वाटर lower than the surrounding temperature or atmospheric temperature, and in the winter you want to maintain the temperature of the liquid water higher than the surrounding temperature or ambient temperature. It is clear? Then how can you decide that this thermos is bad and this thermos is good? Only on the behalf of how much time it maintains. Suppose one thermos, that shopkeeper will say you, that shopkeeper has told you this is thermos X, this is thermos X and this is thermos Y. This thermos X will maintain the temperature of the liquid up to 6 hours, and that will maintain the temperature of the liquid only of 2 hours. So what is meaning for that? Which one is good? Capacity of thermos is same. That thermos will be able to maintain the temperature for 6 hours, and that will be able to maintain the temperature only for 2 hours. After 2 hours, the temperature of the liquid in Y thermos is equal to the temperature of surrounding, and after 6 hours the temperature of the liquid is going to be equal to the temperature of surrounding. Then which thermos is good? Obviously X or Y, because amount of water, amount of heat transfer is same in both cases. Are you getting a point? Amount of heat transfer is same at the end of the day. After 6 hours, or you can say after 24 hours, the amount of heat transfer will be same, yes or no? For example, it is much more better from here. It is X, it is Y. Here you have put the liquid, and here you have also put the liquid of, let's say, 10 kg, and here 10 kg. Temperature of this liquid is here, let's say, surrounding temperature, let's say you have maintained at 15 degrees Celsius, and here also initially you have maintained 15 degrees Celsius, and surrounding temperature is, let's say, at 45 degrees Celsius. At the end of the day, total amount of heat transfer will be same in the both cases, and that is what Q is equal to mCp into delta T, and that you can calculate by the thermodynamics. Why? Because listen, very simple. No work is there. Q is equal to delta E, and delta E is what? System is stationary, and no phase change is there. Then that I can write here mCp delta T or mCv delta T, whatever you can say, because for liquid Cp and Cv is same. Am I right? Yes or no? Please tell me fast. From thermodynamics, we are able to calculate, and here also Q is equal to what? mCp into delta T, and here temperature difference is same here, 45 minus 15. At the end of the day, amount of heat transfer is same, but what is difference? What is different? Rate of heat transfer is different. Are you getting a point? And if you want to calculate the rate of heat transfer, my dear student, then you should go for the heat transfer study, because in the heat transfer we are able to calculate the rate of heat transfer. And that's why if you want to design the heat exchanging equipment like heat exchanger, condenser, boiler, then instead of amount of heat transfer, it is very important to know about the rate of heat transfer. Is this clear? Clear hai? Yes or no? The rate of heat transfer is different in the both cases, and that's why in designing of equipment, that's why the first basic difference in the thermodynamics and heat transfer is that thermodynamics deals with the calculation of amount of heat transfer between two end states, or thermodynamics deals with the calculation of amount of heat transfer when the process changes the state of the system from one equilibrium state to the other equilibrium state. Or you can say, in other words, to change the state from one equilibrium state to other equilibrium state, how much amount of heat transfer required is there, that I can go for the thermodynamics. But if you want to calculate in the heat transfer, we are able to calculate the rate of heat transfer, and the rate of heat transfer is non-equilibrium phenomena. It means in thermodynamics, by the help of thermodynamics, you can't calculate the amount of heat transfer when the two end states are not in equilibrium. You are only able to calculate the heat transfer calculation, amount of heat transfer calculation, when the end states are in thermodynamic equilibrium. Is this clear? That's why thermodynamics is an equilibrium phenomena, while the heat transfer is non-equilibrium phenomena. Second, in the thermodynamics we are calculating the amount of heat transfer, while in the heat transfer we are calculating the rate of heat transfer, and the heat transfer is non-equilibrium phenomena, while the thermodynamics is an equilibrium phenomena. Second thing, thermodynamics says why the heat has been transferred. Thermodynamics will tell you why the heat is transferred, because of temperature difference. That answer of this question, why heat has been transferred, that answer of that question will be given by the thermodynamics. But how the heat will get transferred, answer of this question can only be given by the heat transfer. Means obviously the heat transfer is there, but thermodynamics will never discuss what is the mode of heat transfer. If you want to bother about the mode of heat transfer, then you should be study the heat transfer. Then it means by conduction, convection, or radiation. Are you getting? So how the heat is transferred, that is given by the heat transfer, but why the heat is going to transfer, that is given by the thermodynamics. Clear है? वेट करो, मैं लिखवाता हूँ अभी. ये समझना चाहिए, हर चीज लिखने की कोशिश मत करो. हीट ट्रांसफर क्यों होता है, हीट ट्रांसफर क्यों हुआ, इसका आंसर कौन देगा? क्यों हुआ? टेम्परेचर डिफरेंस की वजह से हुआ, एंड दैट इज द पार्ट ऑफ थर्मोडायनेमिक्स, बिकॉज ड्राइविंग फोर्स इज देयर. We know that heat is transferred from the high temperature to low temperature. That is part of thermodynamics. But how the heat will get transferred, that answer of this question is given by the heat transfer, by conduction, convection, or radiation. Third point is that, third basic difference is that, listen first, try to listen. With the help of heat transfer, we are able to discuss about the temperature distribution. What is the temperature profile? If you want to have a temperature distribution within the object, for example, if we have an object is there, and this object had left surface and right surfaces, and left surface is high temperature and low surface, right surface had low temperature, then obviously the heat transfer is there. But what is the temperature distribution in that object, that is given by the study of heat transfer. Is this clear? So please write the points. Difference in thermodynamics and heat transfer. Please write. First point, difference in thermodynamics and heat transfer. Thermodynamics, TD, thermodynamics deals with amount of, the important point is amount, not rate. Thermodynamics deals with the amount of heat transfer. Amount of heat transfer supplied or removed to change the state of system between two equilibrium states. Clear? Thermodynamics deals with the amount of heat transfer supplied or removed, चाहे सप्लाई करो या रिमूव करो, जिससे क्या हो, टू चेंज द स्टेट ऑफ द सिस्टम बिटवीन द टू इक्विलिब्रियम स्टेट्स. ओके, एंड हेंस thermodynamics is an equilibrium phenomena because it calculates the amount of heat transfer only between two equilibrium states. If the states are not in equilibrium, then you can't calculate the amount of heat transfer by thermodynamics. Hence thermodynamics is an equilibrium phenomena. Have you written this? अगर दो इंड स्टेट आपस में इक्विलिब्रियम में नहीं है, then you can't calculate the amount of heat transfer by thermodynamics. So first is it calculates amount of heat transfer. It calculates amount of heat transfer. And second important point is that between two equilibrium states, These 2 points are very important. First is amount of heat transfer, and that amount of heat transfer only between 2 equilibrium states. If the states are not in equilibrium, then you can't calculate the amount of heat transfer by thermodynamics. That's why it is called as equilibrium phenomena. The second point is, while on the other hand, heat transfer is a non-equilibrium phenomena. On the other hand, at the same point, on the other hand, heat transfer, calculate rate of heat transfer, and it is non-equilibrium phenomena. Means non-equilibrium phenomena, because if the two bodies are in equilibrium to each other, then no heat transfer is there. Thermodynamics calculates the amount of heat transfer to change the state from one equilibrium state to other equilibrium states, while the heat transfer calculates the rate of heat transfer. Here important is rate of heat transfer, and it is non-equilibrium phenomena. Mr. Karthik, actually here thermodynamic equilibrium means the system must be, if I am discussing you ki system is thermodynamic equilibrium, then system is thermally, mechanically as well as chemically equilibrium. All three equilibrium must be exist, then only we can say the system is in thermodynamic equilibrium. Means there will neither be heat transfer, not mass transfer, not the pressure difference. Rate of heat transfer is there. Clear? Second point. Clear hai? Second point. Thermodynamics will discuss about, thermodynamics will say the what are the causes for the heat to be transferred. You can say cause of heat transfer, cause of heat transfer, given by thermodynamics. Cause means what is the reason, and that is what? Temperature difference. What are the causes for the heat to be transferred? That is given by thermodynamics. While how the heat will transferred, on the other hand, please write how the heat get transferred, or what are different modes of heat transfer, how heat get transferred, cause of heat transfer is given by thermodynamics, while reason for the cause or reason you can say, while the mode of heat transfer or how the heat will get transferred is given by heat transfer. क्लियर है? यस नो सर. टू इक्विलिब्रियम स्टेट्स का मतलब ये हुआ, ऐसा समझिए. अब थर्मोडायनेमिक्स में कैसे बताओ, यहाँ पे आप ऐसा समझो. सपोज ये आपके पास पिस्टन सिलेंडर असेंबली है. लिसन मिस्टर अम्बरीश, लेट्स से इट इज ए पिस्टन सिलेंडर असेंबली. ओके, here pressure is P1, volume is V1, temperature is T1. Clear है? Pressure P1, volume V1, temperature is T1. And if I am going to tell कि this pressure is P1 of the system, it means pressure applied by surrounding and pressure applied by the gas inside, it will be same. There is no imbalance of the pressure. Are you getting the point? Because listen, if this is the piston here, and here the weight of the piston is, let's say here the pressure is 2 atm, and here the gas pressure is only 1 atm, then what happen? This piston will get down. Are you getting the point? Because above pressure is more and here pressure is less. So there is imbalance of the pressure. That is not in mechanical equilibrium. this system is said to be in non-mechanical equilibrium. Although temperature is same, although temperature of this system is 25 and here surrounding is also 25, the system surrounding have same temperature. So this system is in thermal equilibrium, but they are not in mechanical equilibrium. Are you getting a point? Not steady state, Mr. Om. Steady state is different thing and equilibrium is different thing. You should not confuse with the steady state. In the steady state, the thing is going to be changed, but not with respect to time. They may change with respect to one point to other point. Process is said to be steady state when the any process variable, listen carefully, any process variable must be not changed with respect to time at any point. From one point to other point it may change, but at any certain points that must not be changed with respect to time. That is called a steady state. For example, it is very important to clear about the steady state and equilibrium. For example, if you have a rod, and this rod you have placed in the furnace, this is your furnace. Listen, Mr. Om, I have this is a rod and I have picked the three point, 1 point, 2 point and 3 point. At this point, let's say temperature is found to be 100, here it is 80 and here it is 20. And this I have measured the temperature of the rod at time t equal to 0 initially. After time t equal to 10 minutes, here temperature is found to be, let's say, 120, here it is found to be 90, here it is found to be, let's say, 30. What happened? Now listen, my dear student, in this case this process is unsteady state. Why? Because at this point, at the first point, second point, third point, at any particular point temperature is going to vary. That is called as unsteady state. And if you are bothering about a steady state, let's say after 20 minutes, again temperature is found to be 120 and here 90 and here 30. Now this process now becomes steady state. Although temperature is going to be changed from one point to other point. Are you getting point? So that is called as steady state, because from 10 to 20, at 20 minutes your process has become steady state, because at this point temperature is not going to further change. Again at time t infinity, even again temperature is 120 and here 90 and here 30. That is called as steady state operation. But what is the meaning of equilibrium? The meaning of equilibrium is that there is no heat transfer. Here even the process is steady state, but there is a heat transfer is there. Am I right? Even the process is steady state is there, but there is a heat transfer is there from high temperature to low temperature. Is this clear? So if the process is steady state, there will be a heat transfer. There may be a heat transfer. You should not confuse. Process यहाँ पे steady state तो है, but heat transfer हो रहा है. बताओ. What is meaning of equilibrium? Equilibrium means nothing should be there. If the process, if this system and this surrounding are at the same temperature, it means everywhere the same temperature is there. There is nothing is going to be happen. No heat transfer. Everywhere same temperature is there. That is called as what? Equilibrium. Equilibrium means siege. There is no driving force. Whenever I am going to discuss about equilibrium, it means there is no macroscopic changes in the system. So if the process is in thermal equilibrium, it means temperature of the system and surrounding are same. If the two bodies are in thermal equilibrium, there is no heat transfer. Are you getting a point? Yes, very good. Yes, Umar. At all time temperature must be same, and it is only possible. Temperature is only going to be same at all time. It means there is no energy transfer. There is no interaction between system and surrounding. Am I right? Then only, na? At all time, yes. And my dear student, once again I will discuss you. Okay, let's say one more example I would like to discuss here. Let's say this is a rod here, and this is rod, and here 3 point is again, and here let's say 100 is there, here 100 is there, here 100 is there. At time t equal to 0, and at time t equal to 10 minutes, temperature is found to be here 120, 120, 120. What about this? Is this equilibrium? Please tell me. What about this process? Yes, that is very good. Whenever you are dead, you are not going to interact with the surrounding. There is no interaction is there. In this case, the change is there. If change is there, it means that is not in equilibrium. That is not in, that is unsteady state. And uniform process is there. That is uniform. That is uniform but unsteady. Why uniform? Because at any given instant, what is meaning of a uniform? What is the definition of uniform? At any given time, if the temperature is same throughout, That is called uniform. At any given temperature, from one temperature to other temperature, the temperature may be changed, but at that temperature also the temperature must be uniform. Yes, very good. So you should be very very clear. You should not confuse with the steady state and equilibrium. Equilibrium is dead condition. You are not supposed to interact in any way. If you are in thermal equilibrium, then you may interact with the surrounding in form of chemical reaction, but you are not supposed to interact with surrounding in form of temperature, heat transfer. Why? Because you are in thermal equilibrium. But if you are in thermal equilibrium as well as mechanical equilibrium as well as chemical equilibrium, means you are supposed to be dead, means you are not supposed to interact in any way. That is called as equilibrium word. Or you can say, whenever I am going to use equilibrium, then it means is thermodynamic equilibrium, means equilibrium in all way. Yes, steady state means rate of heat transfer is constant. Yes, means rate of heat transfer is constant, means it is not going to change with the time. Yes, at all time the rate of heat transfer is found to be same if process steady state. No sir, सोएब भाई, अगर प्रोसेस स्टेडी स्टेट है, यहाँ देखो ना, ये तो स्टेडी स्टेट में है ना, फिर भी तो हीट ट्रांसफर हो रहा है ना यार. आपने कितनी बार वर्ड पढ़ा होगा, स्टेडी स्टेट हीट ट्रांसफर, पढ़ा है कि नहीं पढ़ा है? स्टेडी स्टेट हीट ट्रांसफर. तो अगर हीट ट्रांसफर हो रहा है तो इट कैन नेवर बी इन इक्विलिब्रियम. भाई लिसन, इक्विलिब्रियम मींस नथिंग इज गोइंग टू बी हैपन. Process is seized. It is no interaction. There is no interaction between system and surrounding. Mr. Praveen, if I am going to discuss about thermal equilibrium, it means it is the equality of temperature. If the two bodies are in thermal equilibrium, then there will be no heat transfer. There may be mass transfer because they are not in chemical equilibrium. If I am going to tell you if the two bodies are in thermal equilibrium, if the system and surrounding are in thermal equilibrium, it means there is equality of temperature. It means temperature of system and temperature of surrounding is same. So there is no heat transfer, but there may be a mass transfer, there may be other transfer is there, momentum transfer may be there, but there is no heat transfer. Are you getting a point? But if the system and surrounding are in thermal equilibrium and mechanical equilibrium and chemical equilibrium, it means nothing is going to be happen. That is dead. Now any doubt still? Mr. Soeb, प्रोसेस अगर स्टेडी स्टेट है तो इसका मतलब बस ये हुआ कि किसी गिवन पॉइंट पे टाइम के साथ चेंज नहीं हो रहा है कोई भी वेरिएबल, बट प्रोसेस तो हो रहा है ना. बस ये है कि स्टेडी स्टेट हो रहा है. फॉर एग्जांपल, इफ यू आर गोइंग टू ड्राइविंग, लिसन सोएब, अगर तुम बाइक चला रहे हो कांस्टेंट स्पीड से, इफ यू आर गोइंग टू ड्राइव अ बाइक विद अ स्पीड ऑफ 40 किलोमीटर पर आवर, व्हाट डज इट मीन्स? गाड़ी तो चल रही है ना, बट योर स्पीड इज कांस्टेंट. इट मीन्स you have a steady state process. Why steady state? Because your speed is not going to be, your velocity is not going to vary with the time. But गाड़ी तो चल रही है ना, गाड़ी रुकी नहीं है. Yes, it is clear. So your doubt must be very clear. No, 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 no. Rishikesh, I have told you. Listen, Mr. Rishikesh, try to understand. Sir, equilibrium means there should be no. If the two bodies are in thermal equilibrium, then there should be no heat transfer. And if temperature is going to be changed, as you have drawn this figure, here at time t equal to 0, here it is 100, here it is 100, here it is 100, and at time t this is found to be 150. तो ये अगर 150 बढ़ गया, 100 से 150 हुआ है, what does it mean? It means heat has been transferred, then only temperature has been increased ना. So it is called as uniform, and it is called as uniform unsteady state operation. Uniform, why uniform? Why uniform? Why uniform? Because at all point, at any instant, temperature is same. Uniform. And why unsteady state? Because at given point, temperature is going to change with time. तो खुद सोचो ना, जब टेम्परेचर चेंज हो रहा है इसका मतलब क्या है? हीट ट्रांसफर हो रहा है. अगर हीट ट्रांसफर होगा तो इक्विलिब्रियम में तो होगा ही नहीं, बात खत्म. इक्विलिब्रियम मींस एट ऑल टाइम टेम्परेचर मस्ट बी सेम. दैट्स इट. एट ऑल टाइम, एट ऑल पॉइंट टेम्परेचर मस्ट बी सेम. सिंपल सी बात है यार. इक्विलिब्रियम मींस सीज कंडीशन. सीज का मतलब क्या? नो ड्राइविंग फोर्स. दैट्स इट. नो ड्राइविंग फोर्स बिटवीन सिस्टम एंड सराउंडिंग. तो अगर यहाँ से कहीं हीट ट्रांसफर हो रहा है बाहर से, तभी तो ये टेम्परेचर बढ़ रहा है ना. एंड दैट इज कॉल्ड लम्प्ड सिस्टम. आपने पढ़ा होगा लम्प्ड सिस्टम. व्हाट लम्प्ड सिस्टम? It is unsteady state process and lumped system. Why unsteady state? Because temperature is going to change with the time at any given point. And why lumped? Because it is uniform throughout at any given time. Yes, at equilibrium condition, driving force is zero. Driving force is zero. And at steady state, driving force is constant, you can say. That's it. Clear now? Now it is clear to everyone. So listen here. What is meaning of end states? Now it should be very clear. As I told you, Mr. I don't know कि किसने पूछा था, but here listen. Let's say it is a one state. State 1, pressure is P, volume is B, temperature is T. P1, V1, T1. Now it means, what is meaning of this? It means the pressure throughout it is same. Means pressure outside and inside they are same. Temperature, there is no imbalance. This is system and that is surrounding. This is your system and that is surrounding. Anything beyond system is called surrounding. तो प्रेशर जो बाहर है वही अंदर है, टेम्परेचर जो बाहर है वो भी अंदर है, जो सेम टेम्परेचर है यहाँ भी सेम है, सराउंडिंग टेम्परेचर एंड सिस्टम टेम्परेचर सेम. देन ओनली इट इज कॉल्ड एज, इट मीन्स देयर शुड बी नाइदर हीट ट्रांसफर नॉट मास ट्रांसफर और इम्बैलेंस ऑफ फोर्सेस. फोर्स भी बैलेंस है क्योंकि जो बाहर का वेट है वही अंदर का भी फोर्स है. जितना फोर्स ऊपर से अप्लाई हो रहा है उतना ही नीचे से अप्लाई हो रहा है, तो फोर्स सेम हो गया. दैट इज कॉल्ड एज इक्वलिटी ऑफ प्रेशर, इक्वलिटी ऑफ मैकेनिकल फोर्सेस. नाउ सेकेंड इज temperature भी same है, temperature system and surrounding is same, they are in thermal equilibrium and there is no mass transfer operation, then there is also chemical equilibrium. It is clear? Rishikesh, clear है? Now, but what happen if we have transferred the heat Q? Let's say you have transferred, you have start heating this. Initially that was at the condition of equilibrium, that is one state. That is one state. First state is there. First state. Having pressure P1, volume V1, temperature T1. Okay. Now, let's say volume is fixed here. Let's say, for example, volume is fixed. This is a rigid vessel. Volume does not change. And if you transfer the heat, then what happens? PV equal to nRT. Number of moles will not be changed because the closed system is there. Now, volume is fixed here. And as you are going to transfer the heat, you are start heating, then temperature will increase, then pressure will also get increases. Am I right? And as the pressure will increase, then what happens? Outside pressure is fixed. You can't change the outside pressure. That is one atmosphere, and this is also one atmosphere initially. But when you have start heating, then what happens? Temperature inside will get. Please tell me fast. Constant volume vessel is there. Volume is fixed here. You have start heating. Now the pressure of the system will get increases. Am I right? Yes or no? So that is second state. That is P2. Volume is V. V2 equal to V1. And that is T2. Now you have changed the state, na? P2, V2 and T2. So there is one equilibrium state and there is another equilibrium state. You can also think in this way. That will be much more clear. I will clear each and everything. Listen here. For example, let's say it is a rigid vessel. It is a vessel is there, closed vessel. Rigid means volume is fixed. Its volume, spherical vessel is there, volume is fixed here. And here gas is there and its pressure is P1, volume is V1, temperature is T1. It is equilibrium state. It means there is no heat transfer, no mass transfer, no imbalance of pressure force. Everything is be balanced equilibrium with the surrounding. Okay. Now, in this case, if you cool it, then volume will be same. If you cool it, then heat will get removed out. Then temperature will decreases. As temperature will decrease, pressure will also get decrease. Are you getting the point? Pressure will get decreases. So in this case, again, what happened? This is one equilibrium state. This is second equilibrium state. So this two equilibrium state is there, and in between two equilibrium state, how much heat will get removed out? You can calculate by the thermodynamics. Are you getting? So these two are the two equilibrium state. It means once you have removed the heat, then that is again fixed. There is no change. Here pressure is P2, volume is V2, temperature is T2, and this P2, V2, and T2 should be same. It should be not change again. Then only, na, because if this system and this system are in equilibrium, what it means here? It means that is one equilibrium state and the other equilibrium state. To change from one equilibrium state to other equilibrium state, you have to remove the amount of heat. In previous case, you have to supply the amount of heat, and that, what is meaning of equilibrium? This pressure, volume, and temperature should be not changed with the time, either with the space. And here P2, V2, T2, it should be not. If this pressure, volume, and temperature, this should be not vary एंड अगर ये वेरी, इट मीन्स दिस विल नो ड्राइविंग फोर्स फॉर द हीट ट्रांसफर, मास ट्रांसफर एंड मोमेंटम ट्रांसफर. इट मीन्स अगेन इट इज इक्विलिब्रियम स्टेट. आर यू गेटिंग माय पॉइंट मिस्टर अनमोल? कहने का मतलब यह है कि ये दोनों एक आपस में इक्विलिब्रियम स्टेट है, कि मतलब ये जो इस कंडीशन पे प्रेशर वॉल्यूम टेम्परेचर चेंज नहीं हो रहा है. हमने चेंज कैसे किया? जब हमने हीट को निकाला. जब हीट को निकालोगे तो इसका कंडीशन चेंज होगा, होगा कि नहीं होगा? जब हीट को रिमूव करोगे वॉल्यूम तो फिक्स है. जब हीट को रिमूव करोगे, मान लो आपने इसे कूल कर दिया, इसको आइस पे कर, इसको हमने आइस पे रख दिया, ठंडी जगह पर रख दिया, तो क्या होगा? नाउ पी वी इक्वल टू एन आर टी, वॉल्यूम फिक्स है, temperature will get decreases, then pressure will also get decreased. Now the state has been changed from P1 V1 T1 to P2 V2 T2, and although V2 equal to V1, but P2 and T2 has been changed. It means one state is this and other state is this, and this state is also assumed to be what? In equilibrium. This state is also assumed to be in equilibrium. Are you getting my point? This state is also assumed to be in equilibrium. It means it is assumed that it is not going to be changed either with time or with the space. It will be constant. So one equilibrium state is this and other equilibrium state is this. Although here temperature T1 and here temperature T2. So what is meaning of equilibrium state? That the same equilibrium state has been changed to the other equilibrium state. You should not merge with these two bodies are there, 1 and 2, and here temperature T1, here temperature T2. These are two different bodies. Here the same body has been changed to the other state. Are you getting a point? Please be clear. यहाँ पे एक ही सिस्टम को, सिंगल सिस्टम हैज बीन चेंज फ्रॉम वन स्टेट टू अदर स्टेट. सिस्टम इज सेम, ओनली आई हैव चेंज द स्टेट, एंड हेयर two different systems are there at different temperature T1 T2. Then if T1 is more than T2, then heat transfer will be there. Are you getting a point? Then here you can't say ki sir here T1 T2, because it is not two different system. It is same system is there, same system having two different states. Yes, surroundings should be also changed obviously. Then only they are in equilibrium, na? They are equilibrium with their own surroundings. Are you getting a point? Is this clear? तो हम काफ़ी डीप में चले गए, बट हमने ये बहुत ही इंपॉर्टेंट था कि हमें क्लियर करना कि व्हाट इज द इक्विलिब्रियम एंड व्हाट इज स्टेडी स्टेट. यू शुड नॉट कंफ्यूज. इन स्टेडी स्टेट देयर में बी अ प्रोसेस, बट व्हेन द इक्विलिब्रियम इज देयर इज नो प्रोसेस. एवरीथिंग इज विल बी सीज्ड. सोन कोसी, ऑब्वियसली यार मैंने बोला तुम्हारे पास एक टैंक है, उसको आपने हीट कर दिया, तो सिस्टम तो टैंक तो सेम ही है ना यार, सिस्टम तो सेम ही है ना. सेम सिस्टम विद टू डिफरेंट स्टेट्स. और इसमें जो अमाउंट ऑफ हीट ट्रांसफर जो किया आपने, दैट यू कैन कैलकुलेट बाय द हीट ट्रांसफर. हेयर इंटर इज U1, हेयर इट इज U2. देन Q minus W is equal to what? U2 minus U1. No work transfer, then how much heat will transfer? You can calculate by knowing the U2 and U1. That's it. Same system is there having two different end states. And if you want to calculate how much heat transfer is there, then you can go for the first law of thermodynamics. अभी क्लियर है ऐसा नहीं भाई? सेम टैंक है, आपने हीट ट्रांसफर किया तो जिससे उसका स्टेट चेंज हो गया, U1 से U2 हो गया. आपको निकालना है कितना आपने हीट ट्रांसफर किया है. देन फ्रॉम द फर्स्ट लॉ, इफ इट इज क्लोज सिस्टम, देन Q minus W delta U. U2 is the internal energy of second state, U1 is the internal energy of first of the same system. Simran Singh, what is your doubt? Simran. So according to me, now the things should be very clear कि what is the steady state and what is the equilibrium. सिमरन सिंह, देखिए मेरे कहने का मतलब क्या है. फॉर एग्जांपल यहाँ देखिए, ये आपके पास एक पिस्टन है, ठीक है, एक सिलेंडर है, इसमें गैस फिल्ड है, समझ गए? यहाँ पे कुछ वेट है, सम वेट्स आर देयर, and that is called state 1. And whenever in thermodynamics subject I am going to say state, how can you define the any system as a state? It is very important because it is a part of thermodynamics. That's why I am going to clear. In thermodynamics, any state, any system is said to be in state when, listen carefully Simran, any system is said to be in state when there is no change in characterizing variables, there is no change in temperature, pressure, either with respect to time or with respect to space. न ही टाइम के साथ न ही स्पेस के साथ कोई वेरिएशन हो, दैट इज कॉल्ड स्टेट. और अगर किसी भी सिस्टम में कोई भी चीज़ ना ही टाइम के साथ चेंज हो रही है ना ही स्पेस के साथ चेंज हो रही है, तो इसका मतलब क्या है बताओ? इफ इन एनी सिस्टम सपोज you as a body not going to be interact through surrounding in any way. Any way means this system, in this system the temperature, whatever temperature is there, that is same all time, and at all time and all is all space, at all throughout, all characterizing variables, all the process variables are going to be same at all time and all space, uniform. That is in equilibrium, that's it, because it is in dead state with the corresponding surrounding, because there is nothing going to change here. So what is the condition, what is the Simran, what is the condition for any system to be set in a state? If you want to define any system as a state in thermodynamics subjects, then the condition is that the process variables must not be changed either with respect to time or with respect to space, at least for that moment at which we can define the system as a state. ऑब्वियस बात है कि अगर सिस्टम, अगर प्रोसेस, लिसन एक चीज़ और है ध्यान रखना, इट इज़ वेरी वेरी टीडियस वर्ड, कंफ्यूजिंग वर्ड, कि अगर ये सिस्टम इक्विलिब्रियम है तो नथिंग इज गोइंग टू बी हैपन, बट हाउ इफ नथिंग इज गोइंग टू हैपन, देयर इज नो मीनिंग ऑफ चेंज द प्रोसेस. प्रोसेस तो तभी होगा ना जब ड्राइविंग फोर्स होगा. प्रोसेस इज ओनली देयर व्हेन देयर इज ड्राइविंग फोर्स. If there is no driving force, it means there is no driving force. It means it is an equilibrium condition. That's why the one more word we should write. So we can define any system as a state at least for that time. We can define any system as state when there is no change in process variable either with respect to time or with respect to space. At least for that moment at which we can define the system as a state. मतलब कहने का है, मैं अगर आपको बोलता हूँ आप अच्छे हो तो एटलीस्ट उस टाइम के लिए अच्छा बिहेवियर, अच्छे उस टाइम के लिए हो जिस टाइम मैं अच्छा बोल रहा हूँ, हमेशा अच्छे नहीं हो आप. समझ गए? तो दैट्स व्हाई यू शुड बी पुट वन पॉइंट इज दैट एट लीस्ट फॉर दैट टाइम व्हेन वी आर गोइंग टू से यू एज अ गुड बॉय, अ गुड गर्ल, एट लीस्ट फॉर दैट टाइम, एट दैट मोमेंट, the process variable should be not changed either with time or with space. It is clear? मिस्टर आदित्य धीमान, आप समझ नहीं रहे हो मैं क्या बोलना चाह रहा हूँ. सर स्टेट 1 स्टेट 2 दो अलग सिस्टम नहीं है ना, आप इसी को चेंज कर रहे हो ना सर. हे भगवान भाई, अगर आप एक बाल्टी पानी है उसको हीट कर रहे हो तो बाल्टी का पानी एक ही टाइम पे दो दिखेगा क्या? वो तो एक टाइम पे एक ही दिखेगा ना. वो तो यार T1 T2 ज़्यादा कैसे, जब फिर तो चला गया ना यार. यही सिस्टम को तुम पानी गर्म कर दिए तो पानी ठंडा भी है गर्म भी एक ही टाइम पे, ये कैसे पॉसिबल है? समझ क्यों नहीं रहे हो यार? ओके, तो ये स्टेट क्या है? दैट स्टेट इज सेड टू बी इन इक्विलिब्रियम. सिमरन, एट लीस्ट फॉर दैट टाइम व्हेन वी आर गोइंग टू डिफाइन द सिस्टम एज ए स्टेट. अगर मैं इसको स्टेट 1 बोल रहा हूँ, मतलब इस टाइम पे, जिस टाइम पे मैं स्टेट बोल रहा हूँ उस टाइम पे ये इक्विलिब्रियम में है. उस टाइम पे, बाद में भले वो प्रोसेस होगा. नाउ क्लियर? नाउ इन दिस केस इफ यू आर गोइंग टू रिमूव वन वेट, व्हाट हैपन? इफ यू आर गोइंग टू रिमूव वन वेट, नाउ व्हाट हैपन? एनीवन? आप सब पूछ लो यहीं पे, क्वासी स्टैटिक क्या होता है, क्या होता है, सुन लो पहले. इफ यू आर गोइंग टू रिमूव वन वेट, देन व्हाट हैपन? नाउ सिंस द प्रेशर, लिसन, प्रेशर क्या होता है? फोर्स अपन एरिया. अब समझा रहा हूँ, समझ लो. तो वट एवर द, ये जो एग्जर्ट कर रहा था अंदर का गैस, जो प्रेशर अंदर से, और जो बाहर का जो प्रेशर था, बाहर का प्रेशर किससे? एक तो एटमॉस्फेरिक प्रेशर, पी एटमॉस्फेरिक, प्लस कौन सा? पिस्टन का वेट और प्लस इसका वेट, और यू कैन से प्लस mg, मास ऑफ पिस्टन प्लस मास ऑफ वेट, मास ऑफ बॉल्स, इनटू g, ये हो गया वेट अपॉन एरिया. एरिया किसका? इसका. समझ गए? फोर्स अपॉन एरिया. ये हो गया पूरा. ये जो प्रेशर है, pressure outside is equal to P atmospheric. If you want to calculate what is inside pressure, that should be what? P atmospheric plus mass of the piston plus mass of the balls into G upon area. That should be equal to this. Am I right? Because they are in equilibrium each other. भाई मैं अगर बोल रहा हूँ कि equilibrium में है, इसका मतलब क्या है? जो बाहर का P external equal to P internal. That's it. P external equal to P internal. Are you getting my point? It means P internal, this should be equal to P external. And what is P external? This is equal to P atmosphere pressure equal to force upon area, plus along with the atmospheric force one more force is going to be at, that is called as what, weight force. So here m of piston plus m of balls into z upon area. This pressure outside should be equal to inside. Now when you are going to remove the one weight, what happen? अगर आपने एक वेट को रिमूव कर दिया, अब यही प्रोसेस क्या होगा? नाउ द प्रेशर विल गेट डिक्रीज्ड. Am I right? Now if the pressure will get decreased, then what about inside pressure must be also decrease? Am I right? Yes or no? Because but now the value of the pressure has been changed. अब सेम प्रोसेस, यही प्रोसेस चला गया. अब ये मत समझना कि यहीं पे है. Now in the second state, when you have removed the weight, now one weight has been removed. So what happened? As PV equal to nRT, now my dear student, here pressure has been decreased, so gas will get expand, and as the gas will expand, what volume will get increases and temperature will get decreases. Why? Because now as you have removed the weight, then the pressure, outside pressure will get decreases and inside will be more. Then it will try to attain the new pressure that is lower than the previous one. Then what happened? Pressure can only be released when the volume will get increases, when the gas will get expand. Now then volume will get increase. Volume will get increase. V2 is more than V1. P2 is less than P1. And when the volume will get expand, now suppose here 100 molecules are there, 100 molecules are only in 100 meter cube. Now for the same 100 molecules, if we are going to provide 200 meter cube volume, then what happen? Temperature will get decreases because more space are there. Then they will feel more relaxed. Then temperature will goes down. Is this clear? Then temperature T2 will be less than T1. This is the condition will be there. Am I right? Yes or no? Volume will increase, and then when the gas will expand, so V2 will be less than V1, P2 will be less than P1, V2 will be more than V1, and T2 is less than T1. Temperature will get decreases. Is this clear? Now it means it is second state, na? Here P2, V2 and T2. Now again this T2 is in equilibrium with the another surrounding. Again this state is said to be in equilibrium. It means when this system is said to be in equilibrium, this system is said to be in state, it means at least for that time when we are going to say the system is state, the pressure, volume and temperature should not be changed with time and with respect to space. Is this clear? Now it is clear. The two end states are there. They are called as two equilibrium states. Are you getting my point? Yes or no? So this is the meaning of equilibrium state. So you should not say that this is one state or other system. This is same system is there which has been transformed from one form to other, one state to other state. So that is called equilibrium. Simran Singh. That will be more clear in thermodynamics. But here the only thing is that in the heat transfer, thermodynamics deals with the amount of heat transfer calculation only between the two equilibrium state of the same system. System same ही रहेगा. Now third point you can write. With the help of heat transfer, we are able to find the temperature distribution within the system. The third point. Please write third point. With the help of, only the meaning of equilibrium is that stop condition. At least for, not at all time, at least for that time when we are going to define the system as a state. Because state is change of state is called as process. Do you know? जब state change होगा तभी तो process होगा ना. किसी system का state change होगा एक से दूसरे पे, उसे बोलते हैं प्रोसेस. तो अब एटलीस्ट तो हमेशा स्टेट तो इक्विलिब्रियम में होगा नहीं. दैट्स व्हाई वी कैन डिफाइन द सिस्टम एज ए स्टेट. whenever we are going to define the system as state, then it means at least for that instant the process variables should not be vary with the time and with space, at least for those instants at which we can define the system as a state. Okay, now please, third point, with the help of heat transfer, temperature distribution, और टेम्परेचर प्रोफाइल लीनियर है, नॉन लीनियर है, कैसा है, टेम्परेचर डिस्ट्रीब्यूशन कैन बी फाइंड. ओके, वाइल देवाशीष पथाड़े, एक्चुअली you are going to define the equilibrium in terms of chemical reaction, na? And here we are not going to define in terms of chemical reaction. You can say you have written rightly. भाई सिंपल सा एक लॉजिक है. इक्विलिब्रियम का मतलब ये होता है कि देर इज नो माइक्रोस्कोपिक चेंज, देर इज नो ऑब्जर्वेबल माइक्रोस्कोपिक चेंज, देर इज ऑलवेज माइक्रोस्कोपिक चेंज. मीन्स at the condition of equilibrium, simple line, at the condition of equilibrium the driving force is zero. There is no driving force, that's it. There is no driving force. For any process to be happen, there must be driving force. For any process to be happen, there must be driving force. And at the condition of equilibrium, there is no driving force. And if no driving force means nothing is going to be happen with that process. That is called as equilibrium. That's it. In the steady state, the process will be there. But the only thing is that the process will be happen with a constant rate. That is steady state. That's it. अगर अब नहीं समझ में आएगा तो कभी नहीं समझ में आएगा भाई. इक्विलिब्रियम का मतलब है कि गाड़ी बंद कर दो, और प्रोसेस अगर स्टेडी स्टेट, इसका मतलब क्या है? गाड़ी बंद है मतलब चल नहीं रही है, कुछ भी नहीं हो रहा, गाड़ी बंद है. गाड़ी चल रही है, इसका मतलब क्या है? चल रही है दो तरीके से, इंक्रीजिंग स्पीड से, कांस्टेंट स्पीड से. तो एक है अनस्टेडी स्टेट, एक है स्टेडी स्टेट. दैट्स इट. बट प्रोसेस तो हो रहा है ना, गाड़ी चल रही है. चलने के रिस्पेक्ट में बता रहा हूँ मैं, चलने के रिस्पेक्ट में. तो ओम ने पूरा कॉन्सेप्ट जो है हिला दिया. दैट इज ऑल अबाउट योर थर्मोडायनेमिक्स एंड हीट ट्रांसफर. तो थर्मोडायनेमिक्स क्लियर है नाउ. दैट इज ऑल अबाउट योर हीट एंड difference in thermodynamics and heat transfer. Thermodynamics able to calculate the amount of heat transfer only between two equilibrium states. Okay, while with the help of heat transfer we can calculate the rate of heat transfer between non-equilibrium processes. Okay. Now modes of heat transfer. Please write down modes of heat transfer. There are three modes of heat transfer. Is there conduction, means how the heat will get transferred. Why heat transfer? By thermodynamics. That is temperature difference. How the heat transfer? That is by the heat transfer. Conduction, convection, and third is radiation. Conduction, convection, radiation, you know very well. Now, how can define the conduction? Anyone? How can you define the conduction? Conduction, convection, radiation, these three modes are there. A very simple definition. Conduction means what? First of all, you should know conduction is a basic mode of heat transfer. That is a very basic mode of heat transfer that can be happen in either substance like solids or fluids. First of all, listen carefully. Conduction can be happen in solids as well as in fluids. Fluids means liquid and gases. So conduction is not only in the solids, but it can also be happen in the liquids and gases called as fluid. My dear student, listen. Conduction can also be possible in the solids and liquids and gases, or you can say solids and fluids. When there is a temperature difference, means whenever, because for the heat to be transferred, temperature difference must be there. Without temperature difference, you are not supposed to have a heat transfer. That is obtained from the thermodynamics. Thermodynamics will say ki why the heat has been transferred, why the heat will get transferred. Heat will always transfer from the high temperature to low temperature. That is the Clausius and Kelvin statement. Second law that I will discuss now. But how the heat will transfer? Three modes: conduction, convection, radiation. Then how can you define the conduction, my dear son? Conduction is the basic mode of heat transfer that can be defined as, listen, conduction can be defined as transfer of energy from the higher energetic to the lower energetic molecule due to interaction between the molecules. Simple definition is that. And you should not say conduction is only in the solids. Conduction can be happen in the solids, liquid as well as gases. And how can you define the conduction? Conduction is the basic mode of heat transfer, or you can say conduction can be viewed as a transfer of energy from higher energetic molecule to the adjacent lower energetic one due to interaction between the molecules. Clear है? Molecules के interaction से जो भी एनर्जी का इंट्रैक्शन हो रहा है हायर एनर्जेटिक मॉलिक्यूल से लोअर एनर्जेटिक मॉलिक्यूल में, दैट इज कॉल्ड कंडक्शन. एंड दैट transfer of energy from the high energetic molecule to the lower energetic molecules may be either happen in the solids or liquids or gases. Clear hai? Yes or no? Conduction in the solid is very common, but my dear student, it can also be happen in the liquid and gases. Please write down. Write down. Conduction may be viewed as, write down definition. Conduction may be viewed as a conduction may be viewed as, प्लीज राइट डाउन. क्या हुआ, डाउट है कोई? मैं बता रहा हूँ मिस्टर कार्तिक, प्लीज वेट, प्लीज वेट. कंडक्शन में बी व्यूड एज ट्रांसफर ऑफ एनर्जी फ्रॉम transfer of energy from may be viewed as transfer of energy from higher energetic molecule to the adjacent, just बगल वाला, to the adjacent lower one, lower energetic molecule. Due to interaction between molecules, as please, conduction may be viewed as transfer of energy from higher energetic molecules to the adjacent lower energetic molecules due to interaction between the particles or molecules. Now next point you can write, conduction may occur in the solids and fluids. Conduction may occur in solid as well as in the fluids. Fluids का मतलब क्या? Liquid and gases. Conduction may occurs in solid as well as in the fluids. Conduction may occurs in the solids as well as in the fluids. Now may occur, not always. In the solids, listen here. Next point is that in solids, next point, in the solids always the heat transfer is by conduction. In the solids heat transfer is only by conduction, but in the fluids the heat transfer, sorry, 1 minute, in the solids the mode of heat transfer, you can say like that, please wait, that is better to say. Convection is not possible in the solid. Why convection I will discuss later on. First of all listen, in solids only conduction is there. Radiation can take place through solids in the fluid medium. So please listen my dear student, how the conduction can be happen in the fluids. Solid is very common because I will discuss it here, but for example let's say if you have a glass that is filled with the water, this is the water, or better is that you can think in this way, you have a plate, two plate is there, you have two plates. This plate is maintained at temperature of 100 degrees Celsius and the bottom plate is maintained at temperature of 150 degrees Celsius at all time. At all time, anyhow we have maintained the temperature of the bottom plate and top plate. This is the plate. You can think in this way. The two plates are there. In these two plates we have filled the fluids. This is the fluids. फ्लूड इज फिल्ड हेयर. इस प्लेट के बीच में क्या फ्लूड है, फिल्ड है. नाउ माई क्वेश्चन इज दैट इन द फ्लूड व्हाट इज द मैकेनिज्म ऑफ हीट ट्रांसफर. हियर लिसन, इट्स वेरी कॉमन सेंस टू से कि सिंस द बॉटम प्लेट इज मेंटेन एट 150 डिग्री सेल्सियस, then whatever the fluid just on the surface of the bottom plate will also have the same temperature, will also experience the same temperature of 150 degrees Celsius. Why? Because of no jump condition or no slip condition. Whatever temperature of the surface, same temperature of the fluid at the interface. fluid will also experience the same temperature and same velocity. That is called as no slip condition. The temperature of the fluid at the bottom surface will also have the same temperature of 150 degrees Celsius. But what about the other layers? The number of layers are there. As we are going to move upward, the temperature of the liquid goes and decreases, and the temperature of the liquid at the top surface will have the temperature of 100 degrees Celsius. Am I right? Yes or no? So my dear student, in this case, the heat transfer is by convection. The heat transfer is by convection, not by conduction. Why? Because as per definition, if you want to carry out the conduction in the fluid, then transfer of energy should be there only because of random motion of molecules. Listen carefully. I will also add in the definition of conduction. Conduction in the fluid is only possible when there is no bulk motion. When there is no bulk motion. What is bulk? When there is no macroscopic movement. And what is meaning of macroscopic movement? When the group of molecules are going to be moved. Called as group of molecules, called as random motion of the molecules. Listen here. So if you want to carry out, in this case, here the heat transfer is by convection. What is the difference in convection and conduction? I will discuss it here. No need to write, just try to understand. You can't, everything you can't write here. So are you listening my point? Convection is equal to conduction along with convection is the combined form of conduction along with the bulk motion. In fluid or macroscopic movement. If this is cut, then what happened? That convection will be conduction. Are you getting my point? Means convection has only meaning when bulk motion is there. And bulk motion means what? When the group of liquid molecules are, when the group of fluid elements, when the group of fluid molecules are going to be moved from one point to other point, is called as bulk motion. Are you getting my point? Yes or no? Please try to understand. So what is convection? You can define the convection as a conduction plus bulk motion. And the bulk motion, we can induce the bulk motion in two ways. And what is conduction actually? Listen here. Everything is going to be clear very simple way. Convection is equal to conduction plus bulk motion. Bulk motion we can induce in two ways, either naturally or by forcefully. Forcefully means by the fan, by blower, by compressor. Naturally means with the help of buoyancy effect. Due to buoyancy effect, which has been arises because of difference in density, which caused by temperature difference. यहाँ पे देखो, for example, here due temperature difference, here the bottom layer of the liquid is at 150 and the top layer of the liquid is 100 degrees Celsius. What happened? There is difference in temperature, and due to difference in temperature, what happened? There is a buoyancy effect. Why buoyancy effect? Because there is density difference is there, and density difference which has been caused by the temperature difference is responsible for the buoyancy effect. Why? Because, my dear student, as the fluid will become higher, as the fluid will become heated, it become lighter, and the lighter fluid will always try to move upward. Okay, lighter fluid will try to rise upward, and this will, because of buoyancy effect, the fluid will goes upward. Means the fluid having higher energy, higher means high temperature, will become lighter and it will try to go upward, and this place has been replaced by the fluid which are at lower temperature, because fluid at lower temperature are comparatively denser or heavier. That's why it will come down, and that's why the current is going to be generated, and that bulk motion means group of molecules are going to be moved. This is not random motion, na? This is not random motion. As you know, in the liquids and solids, in the liquids, like here, let's say liquid is there and here gas is there. Two motion is there. One is random motion, called as molecular diffusion, and other is called as, or you can say random molecular motion, also called as molecular diffusion, and other motion is called as bulk motion. Two motion is there in the fluid. One is called random motion of the molecules, and random motion means, as you know, liquid have tendency to, every molecules are not fixed as in the solids. They are going to move randomly here and here. This is the nature of the molecules. This is the random. And while in the gases also, but they are quite apart from each other. Why? Because intermolecular force of attraction is negligible or very, or you can say the mean free path is much more larger in the gases as compared to liquids, but behavior is nearly same. While in solids the position of the molecules are fixed. Is this clear? That's why they are liquid, na? Are you getting a point? In the liquid and solids, in the fluid you can say as a whole, in the fluids the molecules positions are not fixed. They are moving randomly from one direction, one point to other point, with different velocity, with different directions. The random motions are there, and due to random motion molecules, that's why they are fluids. If their positions get fixed, they become solids. In the liquids, the intermolecular force of attractions, intermolecular force are much more stronger than in the gases. Is this clear? In the liquids, intermolecular force of attraction is much more stronger than in the gases. They are quite apart. In the gases, molecules are quite apart to each other as compared to liquids. This motion of the fluids, either in liquid or in the gas, is called as random motion of the molecules, and that is called as molecular diffusion. Is this clear? So this motion, this is the natural motion because they are fluid. They are random motion of the molecules. And if the energy, suppose here, let's say, try to understand here. If we have two plates and here we have filled the gases, they are in between two plates, here T1 and here T2, and T1 is more than T2, and here gases are there. In between plates, gases are filled here. These are gases. The molecules are going to move randomly here and there. I will show you, but no need to try the figure. Only try to understand here. It is better to draw a figure in a better way. Here, two surfaces are there. In between two surfaces, let's say here temperature is T1 and here T2, and T1 is found to be more than T2. Mr. Karthik, especially for you, how the conduction is there in the gases, and here gases has been filled. In between two plates, we have filled the gases, and the gases nature is there. Their molecules are moving randomly. Like that. Okay. Now T1 here, T2 is here. In between two plates, we have filled the gases, and there is a temperature gradient is there. Then only heat transfer is there. Then what happened? Any molecules which are near the higher temperature surface, any molecules of the gases which are at either liquid they are there, any molecules of the liquid or gases you can say which are near the higher temperature will have higher energy of the molecules, because temperature is a measure of molecular energy. More temperature means more molecular energy is there. So any molecules which are near the high temperature will have higher energy, and they are going to be, as they are going to migrate, they are going to be random movement is there. So they are going to be collide to adjacent molecules. They are going to collide with the adjacent molecules, and then what happened? On colliding, they are going to transfer their energy. Similarly, these molecules will collide, and then again they are going to collide to each other, and hence the energy will get transferred from the high temperature to low temperature. That is called as conduction in the gases. Is this clear? So what is the basic mechanism of the conduction in the gases? Please tell me. Two mechanisms: molecular diffusion and molecular collision. Am I right? As a whole, you can say the random motion of the molecules. So due to random motion of the molecules, even the collision is not there. Even the collision is not there. Still the transfer of energy by conduction is there. Why? Because of random motion. Because molecules are going to move. So अभी तो molecules ये वाला यहाँ पे है. Let's say this molecules having high energy will be here. At the other moment, it will found to be here. Then again, transfer of energy is going to propagate from the higher temperature to low temperature. Is this clear? Mr. Bevo, yes, molecular diffusion as well as collision. But at the same time, you should also know, even the collision is not there. Even the collision is not there, still the conduction will be there. Collision will only enhance the rate of heat transfer. If collision will be there, then we can enhance the rate of heat transfer. That's why by increasing the pressure, we can increase the rate of heat transfer. Molecular collision. That's a different part. Listen here. So molecular diffusion means what? Random motion of the molecules. And even the collision is not there, still the diffusion, still the energy will get transferred from the high temperature to low temperature, and that is the mechanism of the conduction in the gases. But the only requirement is that there should be no, very very important. Yes, Anmol, very good. Obviously they don't actual position. That's why I'm going to tell you that any molecules which are at high temperature will have high energy. That's why they are going to be more vibrate. More molecules will have more energy. Then its natural tendency that every molecule is going to be acquire their lower energy state. That's why they will try to go downside. This is a natural process. Then that molecules will have high energy, will try to go in the lower energy state. That's why in this way the energy will get transferred from the high temperature to low temperature by conduction. Even you can say the two basic mechanism is there for the conduction in the, and same phenomena is going to take place in the, same phenomena will also happen in the liquids. So as a common you can say in the fluids the mechanism of the conduction is what? Two mechanism is there. One is called as random motion of the random molecular motion, also called as molecular diffusion, and second is called as collision. Second point you can write, even the collision is not there, still due to random motion of the molecules there will be a conduction transfer in the gases or in the liquids. If collision is there, then it will enhance the rate of heat transfer. That is different part. Clear? Hai? Yes. Only important thing is there ki if you want to carry out the conduction in the fluids, what should be absent? What should be absent? Anyone? What should be absent? Bulk motion should be absent, because I told you if bulk motion will also be there, so actually here the conduction is what? Conduction is because of random motion of the molecules and collision, or you can say molecular diffusion and collision. So if in the fluids I am only going to discuss, yes, excellent. Now can you tell me anyone, if let's say, what about this, if the same condition I am going to write here T1 and here T2 and here T2 is more than T1 and same gases are filled here. Now same gases are going to be filled here. Now is it possible to have a conduction here? Same gas is there, only I have changed the temperature limit here. T1 is more than T2, here T2 is more than T1. What happened? Is it possible to carry out conduction here? Is it possible to carry out conduction in second case? If no, then why? Mr. Karthik, Mr. Sahil, that's why your answer is here only. In these two cases, here no bulk motion is there. Mr. Sahil, there is no bulk motion. You can think why, and here bulk motion is there. Your answer of the question is here only. There is bulk motion. Sahil, Mr. Sahil, here top surface is at high temperature. It means any fluid at the near the top surface will have high temperature, means they are lighter, and lighter will always be upward. And any fluid at the bottom will have lowest temperature. They are heavier. Lowest temperature means they are much more denser. It means lighter is upward and denser is downward. Then no bulk motion is there, no buoyancy effect is here. But in this case, here same condition is there, only I have reversed the plate condition. T2 is more than T1. Here in this case, what happened? Any fluid at the bottom surface will have high temperature. It means they become lighter, and since they become lighter, they will try to go upward, and the buoyancy effect is there. It means difference in density will cause for, difference in density is responsible for the buoyancy effect, and difference in density is happen because of difference in temperature. The buoyancy effect, which has been derived because of temperature density difference, which has been caused by the temperature difference. Now, and here, since the fluid at the bottom temperature will have high temperature, become lighter, will go upward, and that space will be occupied by the heavier fluid, because the fluid at the top surface will have low temperature. They are denser, they will come downward, and there is a bulk motion is there, but there is no bulk motion. Sahil, is this clear? So my dear student, here you can say in this figure is very important. In this case, here two mode of energy transfer is there, two mode of heat transfer is there, along with the bulk motion. Listen here, along with the random motion of the molecules, there is one more motion is there, that is called as, in this, along with the, and that is called as convection. It means in the convection, along with the random motion of the molecules, there is one more motion is there, that is called as, along with the random motion or molecular diffusion, along with the molecular diffusion and collision, there is a one more mechanism is there. अब से random motion तो है ही है. Along with the random motion or molecular diffusion, there is a one more mechanism is there, that is called bulk motion. Yes, bulk motion is there. So my dear student, so my question is that, is it possible to have a convection in the solids? Because I told you, if you want to have a convection, then along with the random motion you should have a bulk motion. So is it possible to have a bulk motion in the solid molecules? Is it possible? No, Mr. Abhishek, bulk motion is not convection. Bulk motion is called advection. That is very important. My dear student, bulk motion is called advection. Advection means the two term is the advection. Advection is the transfer of energy only because of. What is the meaning of advection? Means advection means when only bulk motion is absent. That is called advection. Convection will be the combined form. Convection will include the both advection plus random motion. It is clear? Advection. So you can say also convection is the convection can be defined as conduction plus advection. Convection terms is used for the combined mechanism of the heat transfer in the fluid medium by random motion as well as the advection or bulk motion. No, Vaibhav, convection is not possible in the solids because you can't carry out the bulk motion of the molecules. There is different thing. Current is not molecules. Advection, sir, advection. Advection means presence of only bulk motion. Bulk motion only. Presence of bulk motion only is called as advection. And convection is what? Convection is presence of bulk motion plus random motion. Along with advection, along with bulk motion, that is along with random motion, random molecular motion, also called as molecular diffusion. There is bulk motion too. Or advection. It is clear? Then simple you can write convection is equal to conduction plus advection or bulk motion. Clear hai, yes or no? In the presence of advection, yes, molecules are always in random motion only in the fluids, not in the solids. In the solids, the position of the molecules are fixed. I am asking about the conduction in the within solid. Is it possible to have a convection within solid? No, na. Convection is only in the fluid. If the convection is happening from the hot surface to the fluid, that is in the fluid, not in the solid. Convection can never be happen within the solid because there is no bulk motion is there. That's why whenever we are discussing about the convection, we are only discussing about the fluid. Clear hai? Yes, listen. Air is example. As air, if air is stagnant and there is no driving force, no temperature gradient, then what happens? There is no heat transfer. If air is flowing and there is no temperature gradient, no heat transfer is there. The two things must be important. There should be a temperature gradient. If you want to have a heat transfer, there must be temperature gradient. Without temperature gradient, the heat transfer is not possible. Even all conditions, even the molecules are moving and even the bulk motion is there. Still, the first condition should be there. There must be temperature difference here. Here you have seen I have placed the fluid between the two plates having temperature gradient. If no temperature gradient is there, then no heat transfer is there. Are you getting a point? Yes or no? So even the wind is flowing. It is not example of convection. It is, you can say it is advection is there. Because advection is not the heat transfer phenomena. Advection is simply bulk motion. You can say yes, if the fluid is flowing, then there is a random motion as well as bulk motion. Both is there. And if you are going to incorporate the temperature gradient, then you can say yes, the heat transfer is there because of convection. Are you getting? Even everything is there, but no temperature difference, no heat transfer is there, no convection is there. Is this clear to everyone? If wind is blowing and everywhere same temperature is there, then no heat transfer. You can say advection is there because bulk motion. You can say yes, two types of motion is there. One is bulk motion is there, another is called as molecular motion is there. And the same you will study in the mass transfer Na and J, that I will discuss. Na is called as total flux. Two types of flux in the mass transfer you might have seen. One is called total flux and another is called molecular flux. In total flux, along with the molecular flux, bulk flow is also there. Means molecules will be transferred. One transfer is due to because of concentration difference from high to low due to random motion of the molecules, called as molecular diffusion. And along with that is called J. J means the transfer of the molecules due to difference in concentration or due to molecular diffusion. That is called as J. And what is Na? Na is total flux. Total flux means along with the molecular motion there must be a bulk motion. That means some mass will be also transferred due to bulk motion. The contribution, you can say cumulative form of transfer of the material due to bulk motion as well as random motion is called as Na, total flux. Is this clear? Formula to yaad hai, Na equal to J plus C and V. What is J? J is the what? J is the molecular diffusion. Molecular diffusion due to difference in concentration, due to random motion of the molecules. That is called as molecular diffusion. And the cumulative form of molecular diffusion along with the bulk motion is called as total flux, called as Na. Clear? Now, to my dear student, what is the mechanism of, if I am going to ask you, what is the mechanism of conduction in the fluids? What is the mechanism of conduction in the fluids? Can you describe? You can say there is two mechanisms of the conduction. What is mechanism? Means how the conduction will take place in the fluid. Mr. Karthik, is this clear? The two mechanisms of the conduction is there in the fluid. One is called as a molecular diffusion, called as random molecular motion, and second is called as molecular collision. You can write one more point. Even in the absence of molecular collision, there will be a heat transfer by molecular diffusion, random motion of the molecules. Is this clear? So in the liquid and in the gases, the mechanism is common of the conduction. Mechanism of the conduction is molecular diffusion and collision. Clear? Please write down. Today I will complete the mechanism of, I have discussed conduction. Conduction takes place in now. So it is very important here, if you have a plate, here 100 is there and here 120 is here, and if the fluid is filled or liquid is filled, and here 120 is here and here 100 is there. Now here fluid is filled. In which case conduction is there and where convection is there? Please tell me. The first case, second case. In which case here the fluid is there. Here also fluid is there. Please tell me. In which case conduction, in which case convection? Yes, in the first case there is a convection and here conduction. And rate of heat transfer by convection is always more than in the conduction in the similar condition of the operating condition. Why more? Because in the convection one more additional mechanism is involved. Are you getting a point? Along with the random motion, bulk motion will also be there. That's why the rate of heat transfer by convection is more than rate of heat transfer by conduction. Am I right? Under the same operating condition, here delta T is same temperature difference is there, same thickness is there, same fluid is there, but still the rate of heat transfer in the first case is more than in the second case. Why? Because in the convection, along with the random motion or molecular diffusion, one more mechanism is there, that is called as bulk motion. Clear? So please write mechanism of conduction. First in fluid. First in fluids, it means in liquid plus gases. The two mechanisms is there. The basic two mechanisms. First is called as random molecular motion, also called as molecular diffusion. Second is called as molecular collision. It is supplementary. It may be there, may not be there. Molecular collision. If it is there, then it will be faster. Note, even in the absence of molecular collision, the heat transfer in the fluid by conduction is by random motion. Clear? Two mechanisms is there. Majorly is by this. Although if it is present, then it can be enhanced. You can draw one figure, only conduction, then you should draw here T1 and T2 and T2 more than T1. Otherwise, convection will be there. Conduction, it means the no bulk motion. No bulk motion means the top surface should be at high temperature, that's why it will be lighter. It is liquid. In the gases, the same figure you can draw, but the molecules should be more apart from each other, because intermolecular force is much more weaker in the gases as compared to liquid. T2 more than T1. Here T1, you should place. They are much denser. Here less denser. It is gases. So any molecules at high temperature will have high energetic, will be more energetic, and it will transfer the energy to the adjacent lower one, and in this way the energy will transfer from the high temperature to low temperature. But there must be a temperature gradient. There must be temperature gradient. Otherwise, without temperature gradient, we are not supposed to heat transfer. Yes. Here you can write in the notes कि even in the absence of collision, there will be a conduction in the fluid because of only random molecular motion. So if you want to have a conduction in the fluids, you should restrict the bulk motion. And how we can restrict? As you have seen. Same condition. If we have reversed the temperature limit, then what happened? Now the convection will take place. So this is about the mechanism of the conduction in the fluids. Now in the next lecture, I will discuss mechanism of the conduction in solids. Then I will go for convection and then radiation. I told you already convection. What is convection? Only difference is there in the convection along with the molecular diffusion. One more mechanism will be involved, that is called as, please tell me, in the convection along with the molecular diffusion, along with the molecular random motion of molecules, there is one more mechanism which is involved to transfer the energy from the high temperature to low temperature, that is called as bulk motion. Yes, very good. Called as advection. And convection can never be possible in the solids. So my dear student, if the same two temperature limit is there, let's say, just my question is to all of you, if in the same two temperature limits, if there is no bulk motion, then conduction and convection will be same, yes or no? So that I will discuss in the next lecture. What is the mechanism of convection, and I will also discuss mechanism of conduction in solids. The two basic mechanism is there for the conduction in solids, that is called lattice vibration and flow of free electrons. Okay, that I will discuss in the next lecture. And also I will discuss what is the mechanism of convection. I have told you the mechanism of convection in the fluid is very simple, because in the solid it is not possible. Then only the convection is associated with the fluids, and that is called as, along with the molecular motion, there is one more motion called as bulk motion or advection is there. So you can say convection is conduction plus advection. That's it. Advection means purely bulk motion. Clear? That's it. Thank you so much for today class. I hope you are आपने कुछ gain किया होगा. You have got something new, and that is only introduction parts. Then you should not worry about the subject. Only you should think whatever I discussed. Only you should revise once. It will take only half an hour to revise the things, and then close the notes and keep it as, and revise your previous classes notes. No need to worry about my lectures. Thank you so much. Wait. Mr. Balakrishna, you should not use any books. जो मैं बता रहा हूँ, whatever I have discussed you will not get any in any books. You can go through the books if you want, but I will suggest you should not go for any books. You will not get anything whatever I have discussed. अभी तक तो बुक पढ़ते ही आए हो. Okay, thank you so much. Go and take rest. कोई भी लोड नहीं लेना है. जितना पढ़ाता हूँ, listen, whatever I have discussed today you should complete, you should revise today only. जो पढ़ रहे हो उसे ख़त्म करते चलना है. Okay.